What's up? This is Pang from LabVIEW by Example. Thank you for tuning in. In my last video, I gave an introduction into the LabVIEW for loop. In this video, I'll show you what shift registers are and why you'll need them when working with loops. Okay, so let's start with a thought exercise. Imagine yourself having to learn some country's capital city every day. You wake up, memorize capital city every day, and then go back to sleep. So by the end of a typical month, you'll probably have 30 cities memorized, right? Okay, imagine your memory lasts just for a day. You'll remember the capital city for that day, but after you open your eyes the next day, nothing. No memory of the capital city or that you learned yesterday or days before that. That's not a situation you would want to be in, right? So in LabVIEW, you can implement memory in for loops using shift registers. That way, in every iteration, you can remember values you picked up from the iterations before. You won't forget what happened in the days before. Okay, before diving into LabVIEW, let's start with a text-based language like C Sharp, like I've done in previous videos. So here I have a Windows form project open from last time. Um, so what I'm going to do is, instead of using integers, I'm going to declare a string value or a string variable. Set that to a empty value. And in every iteration, I'm going to add date time. Now, to string. So I have to give this function this format to give me hours, minutes, seconds, and fractional seconds. Plus I want to get a new line every time, and let's set the front panel text to that string. Okay, save and start. So as you can see, I have the time showing, and it's about 500 milliseconds between each print, 10 times. Okay, so you might be asking, why are you showing me this kind of lame program? Well, there's a point. The thing to understand here is that the myString value is remembered each time we go through the for loop. So it makes total sense here, but as we all see in the LabVIEW world, it's sometimes not so obvious. So let's go ahead and jump over to LabVIEW. So I already have a VI set up with the string indicator, and I have another integer indicator that will show me what iteration I'm in. So now let's create a constant variable that starts as an empty string. So I can drop down empty string constant here. Now I want to implement or append the time string to the wire, and output that to the string indicator. So let's go to timing, and what I want to use is format date time string. Okay, and this format is going to be different for LabVIEW than C Sharp. So I want hours, minutes, seconds, and fractional seconds. Okay. And then on every call, or every iteration, I want to append a string or concatenate. So that's the output datetime string. And I want to always make sure that I want to add a new line to this string, so I can expand that and then add end of line here. Okay. Okay, so let's run this. So if I run this, oops, this shouldn't be in quotes. Okay. And I need a colon here. All right. So as you can see, the iteration value increments, but the string indicator only shows the current time and not the previous times generated from prior iterations. So what gives? So what's happening here is that the input tunnel here contains only the value from the first iteration of the loop, which is an empty string in this case. So what we're doing in effect is just appending an empty string each time through the for loop. So resulting in a single line with in the string indicator, which isn't really what we intended. So it's equivalent in the C# example to setting the myString value in the right side of the addition here to an empty string constant. So this is basically what you're doing here. So what we need to do instead is to tell the for loop to pass values from the current iteration to the next iteration. So you can think of shift registers as memory that the loop maintains from iteration to iteration. So in fact, the term shift register comes from the world of digital circuits, where it refers to a type of memory component. To create a shift register, you want to right click on the for loop, like so, and say add shift register. Okay. So what I get is these arrows on the edges of the for loop. Whatever you wire into the left down arrow will contain the first value. So let's wire this here and let's disconnect that. And whatever you wire to the right arrow will contain the value that the next iteration will see when reading from the left down arrow. Okay. So I'll rewire the output of this guy to this. Okay, and then wire this input here. And we can move things around, and your two arrows will always line up. Okay, I have an unbroken start arrow, and let's run. So now we have a history of everything that was run before. Okay, so it's good to keep in mind that you can wire anything to that right upshift register. So think about the logic that you're trying to implement. I could have easily just created a constant and have every iteration other than the first use that. So let me show you that by just wiring a smiley face at the end here. So what do you think is going to happen when I do this? Okay, let's run and find out. Okay, so did you see the first iteration had the time, which is an empty string concatenated with the current time, but in every other iteration, number 1, 2, 3, 4, you have the smiley face concatenated. Okay, so always put on your quality hat and be on the lookout for shift registers and those arrow icons at the left and right when they're supposed to be there. What I've seen on a regular, in a lot of um, incorrect code is regular tunnels that may kind of look like the values being passed from iteration to iteration, but they're really not. So let me show you here. Let me get rid of this. So if I delete the shift registers and do what I had before, okay, so don't pay attention to this little icon here for now. I'll go through this in another video. So this code is logically no different from the first version of the block diagram. It's coming in and all you're doing is just concatenating the time and then concatenating an empty string every time. Okay, so let's return to having shift register. So an easy shortcut is to right click on a regular tunnel and say replace with shift register. And then it will ask you where the other shift register on the output side is, on the right side. So let's do that with this one here. And there you go. Okay. So what will happen if I don't wire anything to the left down arrow on the shift register? So what if I didn't have that? Okay. What we have is what is called an uninitialized shift register. So what an uninitialized shift register does is remember what value the shift register contains on every run of the VI as long as the VI stays in memory. So on the very first run of the VI, the value that the shift register assumes is the default value of your data type, which for string is just an empty string. Okay, so let's see this in action. So let me run this once. Okay, so I have my 10 strings. So let me get this a little bit taller. So if I run this again, these will stay and you just append to the history. Okay, because this whole string here, I don't know where 10 was, stayed in this uninitialized shift register. Okay, so to reset everything, let me save. If I close and if I open that up again, if I run, it starts from the default empty string. Okay, and as long as this is in memory, it'll append to that string. So you'll find uninitialized shift registers pretty useful when calling and creating sub VIs, which I'll probably cover in another video. Okay, congrats. Go off and try shift registers for yourself and find out how you can use shift registers in your applications. All right, that should be enough for this video. Add your comments and likes below, or just go to LabViewByExample.com for more tricks, tips, and videos about LabVIEW. And remember, you too can be LabVIEW Awesome. Thanks for watching. Later, guys.